Okay, this is a classic method. Trial and error is something that, you use it in school and you feel like you're just doing things the wrong way. But on the SAT, so many of the problems are designed so that doing it the trial and error way is actually faster, easier, safer, avoids lots of traps. Let me just show you a couple, see if I can convince you. This first one, well, this one's from my book, and this one doesn't usually convince people who feel that they are good at algebra, but bear with me, let me show you what I'm talking about. They ask you to solve this equation and find x, and you take a look at it, and if you are good in algebra, you look right at this and you say to yourself, oh, I'm just going to take the square root of both sides and be on my way. And that's fine. I will mention that if you're not as automatic in algebra, you might be tempted to start by foiling on the left, and oh, that makes things worse. But all I'm going to say is, hey, wait a minute, it's a multiple choice test. One of these down here has to be the answer, and you literally just pick whatever looks easiest to you and try it. You say, could this be it? And you play with it. So I'm going to try x equals 4. And if I try x equals 4, I get 2 times 4 is 8. And when I take away 2, I get 10. And the key thing is that when I square 10, it's not 64. The answer is not 4. 2 times 5 is 10. Take away 2 and you get 8. And oh, look at that. When you square 8, you do get 64. Ta-da, I'm done. Thank you. Next. Now, if you're thinking, oh, that was too easy to be a real SAT problem, I promise you it isn't. It would be in the first half of the test. It's not a very hard SAT problem, but I promise there are problems like this to be found. And doing it by trial and error is just so safe and silly. But even if I haven't convinced you with this problem, take a look at the next one. All right. Here we have a system of equations, and it's a little harder. If you were going to do this the school way, I'm going to describe the process. I'll even start it, but then I'll bail out in the middle, and you'll see why. First, you solve for y on the top equation. We're going to use the method of substitution. So we have y equals 12 minus 2x. And then I can plug that into the bottom equation, and now I have x squared plus 2 times, and then you have the quantity 12 minus 2x. I'm laughing because I'm assuming by now you already kind of hate this. Set that equal to 33, and look, we're almost done. Now all we have left to do is FOIL, then distribute the 2, then clean everything up, and then it turns into a quadratic equation, which by luck, it actually does factor, and you would eventually get the answer. I want to tell you really quickly, I wrote this problem like, I don't know, 15, 20 years ago, and I've shown this problem to a zillion students. I've never once bothered to finish the process I just described to you. I lose interest. It's boring and it's annoying and it's unnecessary. You could just go to the answers and play with them. Watch, I'm going to pick an answer. I'll try 4. Okay, they want a possible value for x. I'm going to try, could x equal 4? Well, if I make x 4, what does that give me? 2 times 4 is 8. Okay, 2 times 4 is 8. But I need this thing to add up to 12. So if I make x 4, I need 4 more. If x is 4, y is 4. Then I go and I check to see if those work in the next equation. 4 squared is 16. 2 times 4 squared, well, let's see, that's 16 times 2 is 32. Plus 16, all that matters is it's not 33. I guess 4 is not the right answer. So you don't panic, you pick another number. Let's try 5. If I use 5, 2 times 5 is 10. I'm going to need 2 more to get to 12. 5 squared is 25. 2 squared is 4 times 2 is 8. And like a miracle, 25 plus 8. Oh, look, that is 33. It worked. I'm done. Thank you very much. 5 is the answer. Trial and error is rewarded. And by the way, you can ponder, why do they design the test this way? Think about how much easier this is than the way used by the poor kid who thinks that you have to do things the school way. All this is difficult and lengthy compared to what we just did. In fact, it gets worse. Let me show you another. This one comes from an actual SAT. And I really think that this proves, this kind of example proves how this test is biased in favor of the sneaky and in a way that harms good students who try to apply what they do in school. So bear with me. I'm going to do this by the school way first. The school way to solve an equation like this is to square both sides. And you get 4x equals x minus 3 quantity squared. And then you could say to yourself, okay, now I know how to do this. And I will persist with this one because I kind of want to make a point here. You get x squared minus 6x plus 9. Subtract the 4x from both sides to make it sort of ready to factor. You get x squared minus 10x plus 9. And then you might notice, oh, look, this factors. Don't worry, if everything I'm doing is making you nervous, please don't worry about it, because in the end, we're going to do it a better way. But yeah, this is x minus 1 and x minus 9. Aha, 1 and 9 are both solutions, and you'd be tempted to choose C. All right. On the other hand, if you were a lazier kid like me, you wouldn't be doing any of this. You would just go to the answer choices and try them. Look. Is 1 a solution? Let's try it. Square root of 4 times 1 is 4. And 1 minus 3, this is 2, and this is negative 2. No, they are not equal. 1 didn't work. Okay, so the answer choice can't be that. Let's try 9. To use 9, you get square root of 36. And you just have to check, is that equal to 9 minus 3? Oh, why, yes, it is. 6 does equal 6. So 9 works, 1 doesn't, and the right answer is B. Look at what just happened. The kid who did it the school way fell for a trap. It's such an obnoxious thing to put on a test. When you solve an equation by squaring both sides, you sometimes introduce extraneous roots, extraneous solutions that don't work when you check them. So at the end of that process, you're supposed to go back and use trial and error anyway. Well, why not just skip all this and go right to the trial and error? Okay. One more for this little mini video for you guys. I just want to show you that this also works on word problems. This is another one from an old SAT. Yeah, these last 2 questions I took from official SAT practice exams. A group of 202 people went on an overnight camping trip, taking 60 tents. Some of them held 2 people each. The rest held 4 people each. They were all filled. How many of each kind of tent were there? Okay. Well, actually, they just want to know how many 2-person tents there are. Your math teacher would say, oh, if you let X equal the number of 2-people tents and Y equal the number of 4-person tents, you could write an equation, a system of equations. You know that the X plus the Y, this is not the way I'm going to do it, but you know that together the number of tents add up to 60. And let's see, 2 times the number of 2-person tents plus 4 times the number of 4-person tents has to add up to the 202 people. And then you solve that system. Unless you don't feel like doing it that way. What if you just say, wait a minute, the answer choices are right there. I think I'll try one. I think that's what I'm going to do. And by the way, I always try easy numbers first because I like to, I like to have things be easy, especially when I'm first figuring out what's going on in a problem. Could there be, I'm going to check, could there be 20 of the 2-person tents? Well, let's see. They've got 60 tents altogether. So if they have 20 of these, then they've got 40 of the others. So this is 20 of the 2-person tents. You'd have to have 40 of the other. Let's see how many people that can hold. 20 times 2 is 40. 40 times 4 is 160. Oh, but that only adds up. You add those up, they only add up to 200. Oh, and we need a little more room. hey, you can almost see what's going to have to happen here. We're going to need one more tent that holds 4 people and one fewer that holds 2 people. But you know what? We'll still check. Let's check 19. If there are 19 of these, there'd have to be 41 of the other tents, the bigger tents. And then I'll do 19 times 2 is 38. And I'll do 41 times 4 is 164. And like a miracle, when I add those numbers together, it gets 202. And I think I'm going to put C, and I'm done. And I did not bother doing algebra. Now, a quick message for those of you who just love algebra and are great at it. That's fine. If you see the algebraic solution, go ahead and do it. But you might want to consider practicing this way as well, because it's pretty fun. And I have to admit, I have never once on an SAT problem solved a system of 2 equations and 2 unknowns. There's always a way to work around it. Okay, and with that, we have completed our look at really the second of 2, well, I guess the first of 2 classic methods, trial and error. And earlier I posted a video about using the backdoor play. These are like the fundamental methods for avoiding algebra on the SAT.